most of today should be a review. We're gonna apply the idea of transformations to a couple of new things. For starters, we need to talk about parent functions. Okay. Now I'm giving you like a whole library of parent functions, if you will. They're all on this front page. You are responsible for remembering all of these. Okay. I'm not going to give them to you. Now, the nice part is I'm just going to kind of scroll down here. You should already know 3 of these by heart. Okay. So I'll zoom out for a second. I'll zoom back in if you need to see in a second. But my 3 over here on this side, you have seen these before, right? C is just a constant, it's a straight line. This one is just my linear. Okay, we saw this last 2.4. And then my quadratic. So those are 3 that you are super familiar with already. So the only 3 new ones you kind of have to worry about are these 3. Okay, so I'll zoom in now. So on this top one, for example, I'm giving you 3 points that are like most helpful, okay, for that graph. It kind of looks like that half arc. We saw this one when we were talking about the domain and range and the increasing and decreasing. We've seen this one already. Okay, but that's what that one looks like. That's the square root function. Okay, my absolute value function, you probably recognize this one from Algebra 2. We used a lot of those. This just looks like that V. Okay, it's straight lines, 2 linear that meet at a vertex. Okay, again, 3 key points there are that origin and then -1, 1, and 1, 1. And then my last parent function that might be new is that cubic function, which we've seen already, but we didn't spend a ton of time with. It just looks like that funky little snake. All right, it's going up through the origin. Those are your 3 key points there. Let's say you forget what these graphs look like. Not to fear. If you remember our formulas, okay, so obviously quadratic is x squared, cubic is x to the 3. You can always just plug values in, okay? Plug in 0, plug in 1, plug in -1, and you'll start to remember the shape, okay? Now, the reason I bring this up is when we take this 2.5 test, this 2.5 test to 2.7 won't happen until after spring break, okay? But it will happen, I think it's on that Wednesday after we get back. There will be a part of the test with no calculator. So if you're someone who likes to rely on the calculator to graph the pictures, know that you will not have a calculator for part of this test, okay? So we do have to remember what these look like. Don't just bank on having the calculator as a resource, okay? All right, any questions on our parent functions? Think about parent functions as my starting point. Okay, that's going to be helpful here in a minute. Okay, my parent functions are like a starting point. They're the simplest form. Okay. All right. So let's just jump into transformations. So when we say transformations, we're talking about changes in my graph. So for example, my vertical shifts, that's the first kind of transformation we're going to talk about, okay? And that's because, in my opinion, it's one of the easiest, okay? It's the easiest to see. We have a number at the end after my parent function. It's on the outside of my variable. If it's plus, we're going up. If it's minus, we're going down, okay? So it kind of just makes sense in our head. Also, I should write here, my parent function for all of these is my quadratic, okay? So as we go through these, I'm using the quadratic function as the parent, okay? So again, if I have a plus on the outside, I'm doing a vertical shift that way. So I would say I have a vertical shift of +2. This one I have a vertical shift of down 2, okay? All right, horizontal shift, okay? Horizontal shifts, very similar. However, instead, we have the number inside the parentheses, okay? So I used the same numbers as I did above on purpose. just to show that it's not the numbers that tell us what to do, it's where the numbers are that tell us what to do. Okay? Now, this one's tricky because it's kind of opposite in our brain. If we see a minus, we're actually going to go to the right, or we're going in the positive direction on the graph. If we see a plus, we're going in the negative direction on the graph. Okay? And again, it's inside. So notice my square is around everything. Okay? So just to pause, just to show this difference, look at our Desmos here. You can just look at the board for this one. So here's my original. There's my parent function, okay, in red. If I were to do a vertical shift of +2, oh, I froze. There I am, okay? So all I did, my blue is my new one. I just shifted it up. Notice the difference. If I do parenthesis x plus 2 square, oh, keep going. It shifts it this direction. Okay, so even though it's a +2, I went to the negative direction. Okay, that's why it's a little trickier with the horizontals. Okay. All right. Let's move on. Reflections. Okay, reflections are our next kind. We have two kinds of reflections. Okay, so we've talked about three before. We talked about X, Y, and origin symmetries or reflections. We only have X and Y here. Okay, so we only have X-axis reflections and Y-axis reflections. What I mean by that, those axes telling me over what I'm reflecting. So for example, if here's my coordinate, there's my Y and my X. Let's use my parent function. So here's my parent function. Oh, that's actually not a good example. Here, let's do the square root. Okay, so there's the square root function. If I'm reflecting over the x-axis, that would mean I'm reflecting it over him, and so my graph would look like that. Okay? If I'm reflecting over the y, that would mean I'm reflecting over him, and so it would look like that. Okay, so that's what we mean by x and y axis reflections. We know the difference by where the negative is. Okay, so if it's an x-axis, the negative is outside. If it's the y-axis, it's inside. Okay, these are all things you're going to have to know. So as we're going through these, I know we're going fast. It'll click as we start to actually practice some of this. Any questions on these three kinds of transformations? Vertical, horizontal, and reflection. Okay. Think of these ones. So the reason these are grouped together is because these all have to do with position. Okay? Think about where the graph is. We're not changing the shape, right? We're not changing shape for any of these. Okay? If you look back at my Desmos, my shape was the exact same. We just moved it. Okay? It's still here, one spot over for these 2 points, one spot over for those 2 points. Okay? Our shape doesn't change, just the position. Now let's talk about ones where I am going to change what it looks like, or the shape. Okay? Stretching and shrinking. You also might be familiar with stretching and compression. You might hear both of those words. Shrinking means the same thing as compression. Sometimes I prefer compression, just because it helps me think about what I'm doing. If you're like compressing something, you're pushing it down, right? You're kind of smushing it. You're shrinking it, okay? This one can be tricky too. If you notice my examples over here, I used the same numbers on purpose. For a vertical stretch, I have numbers bigger than 1 out front. For a shrink or a compression, I have a fraction. It's opposite when it comes to horizontal. Okay? So let me just backtrack for a second. So when we talk about just vertical stretches, notice my number is outside. Okay, number's outside. When I talked about a vertical shift, where was my number? Outside, right? Back here. When I talked about a vertical shift, it was outside. When I talk about a vertical stretch, it's also outside. Okay, so outside, think vertical. Inside was a horizontal, and inside for my horizontal shift, it was inside too. Okay, so that is the same, so that's nice. Okay. Notice with these numbers, we never have a negative in there. Okay, we're only looking at whole numbers or fractions. Okay, because remember, negatives tell us reflections. Okay, these ones are the hardest transformations, the stretches and the shrinks. Okay, we'll see an example of that here right away. Okay, but these are by far the most challenging ones. Done? Thank you. And I gave you a packet. All right, so can I move on? We okay? All right, so that's all of them in general. Let's actually put this into practice. So up top on this next page, I gave you the best order to think about each transformation. Okay, so the first thing you're probably going to want to think of is horizontal. That's always the first one. Then the next thing we'll do is we'll look at if it's going to stretch or shrink. Then we do reflection, and we do a vertical translation last. So our horizontal and vertical translations, they're like our sandwich. There are two ends of the sandwich, first and last. In the middle is where we do stretch and reflection. Okay? So let's come down here. Here's my function. I'm always going to start with my parent function. Okay, that's part A. I tell us in our directions here. Part A, identify the parent function. Okay, that's a good place to start. So what is my parent function for this one? What would it be? What would my parent function be? Not just x. Not -4. Look at my exponent. Yeah. Okay, so when we look at our parent functions, it's always just going to have an x somewhere. I don't see any absolute value bars. I don't see a square root. But I see a little cube. So I know that my parent function is this. So right now on your graph, now I recognize that our graphs didn't print great. So you might need to add in some little like tick marks on yours just to help yourself out. You can see some of the lines, but not all of them. Okay? But let's graph our parent function. So remember, for this parent function, for my cubic, we've got 3 points like this, right in a diagonal, and they make like a snake. Okay? So that's my parent function. For all these problems, we have to graph our parent function first. Okay? All right, now this is where colors are going to be helpful if you're someone who wants to do that. Part B, let's talk about our transformations. Okay, so I'm going to try to stay organized here, so it might take me a minute or two longer than you, but let's see. Okay. So the first thing that we're going to talk about is horizontal shifts. Okay, so look at my problem. Do I have a horizontal shift happening? Yes. What tells you that, Elaine? The -4, right? Because it's a number inside. So that's my horizontal shift. So I have a horizontal shift where? Where am I going? What does -4 tell me? The right. This is the one that's opposite. Okay? Right 4. Okay, so that's the first one. We're just going to list them first. Okay, so that's the first part. Now look at number 2. Number 2, I've got stretching or shrinking. Do I see a stretch or a shrink? Yeah, I do. What tells me that that's happening? The 2 out front. Oh, newbie highlighter. The 2 out front. Okay, and now it's a number bigger than 1. So what is it, a stretch or a shrink? A stretch. Oh, and I actually should specify. I'm going to say a vertical stretch because we do have vertical. Did I spell it right? Yeah. vertical stretch by 2. Okay, because we do have horizontal stretches that might happen. So we have to specify. So it's going to stretch this way. Okay, if we take both ends and pull them far apart in the vertical direction. All right. Do I have a reflection? Do I see a negative? Nope, so I don't have that one. And do I have a vertical translation? Is there a plus or minus outside the parenthesis? No. Okay, so we're done listing them. Okay, so now let's just graph. So that's what part C is up here talking about. Part C says to graph. Okay, so I'm going to keep my colors consistent. I start with the horizontal shift. So I'm going right 4. So I'm going to take each point and go in the right direction 4. So I'm going to go 1, 2, 3, 4. That's where my new origin is. Okay, I went over 1, 2, 3, 4. I'm going to do the same thing with each point. Okay, so that's my horizontal shift. Now, the stretch, like I said, this is the hardest one. Okay, at some point, you'll probably be able to just do this in your head, but I'm going to slow it down just a little for our first time. What's this new pink point? What is that new pink point right there? Five, 1, right? Okay. What's the second point that I got there? What's that one? 4, 0. And my last one? Beautiful. 3, -1. Okay? So those are my new points. Here's how a stretch works. If we're moving in the vertical direction, what value is going to change, the x or the y? The y, right? Because vertical, right? We're going up and down. So it changed the y. So all I'm going to do here is I'm going to multiply all of my y values by 2. Okay? Only the y values. Okay? So my new blue point, this one doesn't change. My 5 stays the same. But 2 times 1 gives me 2. 0 times 2 still gives me 0. And then I have 3, -2. Okay? So that blue is me applying our new vertical shift. So now let's plot those points. So notice this one stays the same. Okay? So he'll still be there. Disappear on me. Yep. 5, 2. He goes up 1. This one comes down 1. So now let's connect hello, your test is down in the testing center.
Where's that?
The down at the end of the hall. Downstairs. Okay, and then we connect our blue dots. So if you notice, compare our new line to our old one. We shifted it and then we stretched it. Not by much, by a little bit. Okay, but we stretched it by a little bit. Yeah.
Do we have like exact graphs?
Exact graphs. I'm looking for these points. Exactly.
So like exact, yeah.
Mm-hmm. Okay. Only those 3 though. Like I don't care about down here. Like if you're off by a little bit, that's fine. Okay. All right. Any questions on that first one? Notice my graph has 2 lines on it. The parent and then my final one. That's what I'm looking for always. Okay, you don't need to graph the one in between. Okay? All right. Flip your paper over. Let's look at this next one. Okay? Let's start with my parent function. Okay, that's our first step, my parent function. What is the parent function going to be for this one? Y equals what? Yeah, perfect. Square root x. Okay? So remember, that parent looks like 1, 2, 3, 4. Looks something like this. Okay? That's what our square root function looks like. Now, if you look at my problem up here, what is making me a little unhappy? What's making me... Okay, we see the negative. And notice inside my square root here. See how my 5 comes first? I don't really like that. So I'm just going to rearrange it. I always want my x to come first. So I'm just going to rearrange it like this. So I'm not changing my problem at all. I just move things around so that I have my variable first. Okay? All right, any questions on that one? Just reorganizing it. Okay. All right, so now let's identify our transformations. Okay? So the first one we looked at was vertical. Do I see a vertical shift in this one? Yes. What tells me that? Yep. Sorry, did I say vertical? I meant horizontal. Horizontal. Yeah, sorry. The +5. Okay? So I have a horizontal shift. I'm just going to use that. Where am I going if it's +5? Left 5. Okay, so remember that's that opposite one. Okay, so horizontal shift, left 5. Okay, next I looked at if I had a stretch. Do I have a stretch happening or a compression? Do I see a number out front? No. Okay, so no stretch or compression. Phew, because that one's annoying. What about a reflection? Do I have a reflection?
What's funny out there?
Sounds hilarious.
Yeah.
I do actually. I don't have a negative out front, but I have a negative in front of my x. Go back in your notes real quick. I'll flip backwards too. If we look back, next one. If I have a negative inside with it, it's a reflection around the y. Okay, so if my negative's inside, I reflect about the y. So I'm going to say here, I have a reflection, and I'm just going to put in parentheses y-axis, because that's how I'm reflecting. Okay? All right, and then last but not least, do I have a vertical shift? Yes. My +2 on the outside tells me that. So I have a vertical shift, and it's a +2, so I'm going up 2. Okay? So I have 3 transformations now. Any questions on identifying what our transformations are? Okay. So again, today as we go, definitely use your notes. Go back as you're getting used to this. Okay? All right, so let's just start with my horizontal shift. So I have a horizontal shift left 5. So I'm going to take every point and move it to the left 5 spots. So 1, 2, 3, 4, 5. 5. 1, 2, 3, 4, 5. Okay? And you don't need to connect them yet. Okay? We won't connect them till the very end. But we're going to use those 3. Do you care if I call them anchor points maybe? They're like our anchor points what we use. Okay? So that's my horizontal shift left 5. My shape hasn't changed. We've just moved them. Okay, reflection about the y. This one's a little trickier. Okay? Think about it in terms of my new x values. So, for example, this point right here. What is that point? 1, 2, 3, 4, 5. -5, 0. You agree? If I were to reflect it, I'm going to have the opposite x value. Okay, so I now would be at a +5. Okay, so all I'm doing here, I'm making the opposite x value because I'm flipping it about the y. Okay, again, think about folding your paper in half this way. Okay, if I fold this side on top of that side, where would my new points be? Another way to think about it, if that's confusing, start at your origin. If you go 1, 2, 3, 4, 5 this way, do 1, 2, 3, 4, 5 the other way, plot a point. Okay? All right, so that's my reflection. Now we're going to vertically shift up. So this is where staying organized is important, because we're going to use these 3 dots now to go up, not the pink. We're done with the pink points. So I'm going up 2, up 2, up 2. And then we connect our dots. And remember, with my parent function, it's getting bigger and bigger. So that is actually my parent function. not my parent function. That's my new function. Okay? All right, any questions on that one? That one looks a little funky because it's the square root of x. Okay, but again, this is where colors help for sure. Keep you organized. All right. I want you to look at 3. I just want you to start by listing out my transformations. We're almost done. I think we've got 2 more problems to do, okay? So list my transformations first. I'll show those in a minute, and then we'll graph them. If you think you can graph them on your own already, go for it. I'm going to do it as a group, though. Blake, did I give you a packet?
Yeah, I'm working on it right now.
Okay. I'm just going to remember to put one on your desk. Yeah.
Would it be? Or would it
Yep.
be stretch?
Reflection. All right. So here's what our reflections and vertical shifts and horizontal shifts are. Okay, so those are our 3 transformations. Okay, any questions on these 3 first? Anything we didn't get? Maybe we're confused on where we find it. Biggest difference with this one, guys, is our negative is out front now. So that tells me it's a reflection about the x-axis. Okay, last one we saw the y-axis reflection. All right, so here's my parent function. Okay, go ahead. I want you to start graph and see if you can finalize. See if you can actually apply this now, and then I'll do it kind of quickly in a couple minutes. So start with your horizontal shift.
I forgot what it was.
Yeah, so order matters. Okay, go in the order that I gave it to you. All right, so my horizontal shift, I went right 3. So I'm going to move all my points. Okay, so that was my horizontal shift, right 3. My reflection about the axis, I'm just going to take this top and flip it over like I was folding my paper. So I'm reversing all the y values now. Okay, so now it kind of looks like a mountaintop. That's my reflection on the x-axis. And then my vertical shift up 2, I'm going to take those blue points and move them all up 2. And then make sure you connect your dots for your final function. Okay? So that's my last one. Get out of your way. Okay. So again, not that Not that order doesn't matter, because really we should always get to the same graph. I've just found it's easiest to do it in this order, okay, where we do horizontal first, then we deal with reflections and stretches, and then we shifted vertically. All right, any questions for me on this one? Just getting our feet wet a little bit. All right, flip over. I think this is our last one. Yeah, go ahead. List my transformations. Notice with this one. Oh, actually, let's start this one together. I don't like the order of this again. Remember, I always want what to be the first thing that I see. An X. Now, we have to be careful. Okay, don't write this on your paper. Just look at the board for a second. This is a mistake I see a lot of kids make. They'll write this. Is that negative with the 2 or with my parentheses? Parentheses. Okay, so don't write that. Don't fall for that mistake. My negatives with the parentheses, and then this is a positive 2 at the end. Okay? So when we rewrite it, we've got to make sure we take your time in that part and rewrite it with all the pieces where they belong. Okay? All right, now you can go ahead, write my transformations. Just list them out. Just make sure you're always putting the parent function on these guys too. Okay. All right. Here's what we should have gotten. My parent is that quadratic. Okay, I guess I can X out actually. Okay. I have a horizontal shift left 4, a reflection. It's outside, so I know that it's the x-axis, and a vertical shift up 2. Okay, so go ahead. I want you to graph this one on your own. I'll freeze and do the same thing. We'll see if we get the same answer. All right, so my purple line on the screen right now is my final graph. I did my pink one first. So my pink dots, most of them actually got covered up here. But this was the first one. I moved it to here, shifted it left 4. Then I reflected it down. That's my blue. And then my vertical shift, I took that whole thing and moved it up 2. Okay? So, all right, any questions for me on this one? All right, just to give you a little game plan for the rest of this week. So today we did 2.5. Tomorrow we're going to do 2.6. And then Friday is just going to be like a work day. Like we're just finishing things we owe. I have a short little activity you can do. Okay. Typically I would have made tomorrow our 2.5 work day. And then we would have done 2.6 on Friday. But I figured half day before break, we don't want to do notes. So we're going to do 2.6 notes tomorrow. Okay, so know that you'll get a lot more practice with 2.5 on Friday. If you are going to be absent Friday, it is your responsibility to look on Schoology. There is still going to be an activity you have to do and submit. Okay, it shouldn't take you long. Okay, but know that if you're planning on being out on Friday, you still have something you owe. Okay. I will do my best to have it up even tomorrow so that if you know you're going to be absent on Friday, you can still do it tomorrow before the day actually comes, okay? Today, your only homework is in our packet, okay? It's pages 7, 8, 9, and 10. So 4 problems, okay? This is your homework, okay? It's in here. There is a spot in Schoology. If you would like to just submit your answers there, you can. It's not like a picture upload. You'll actually... It's like drop-down menus, okay? You'll fill in the blanks where I tell you. Or if you don't want to do that, you can show me the hard copy at the end of class today, okay? But it should take you long. It's page 7 through 10. That is our only homework for tonight, okay?